Okay, how you doing? A question about amplitude has come up that I wanted to take a look at, and really the main question is, what about an amplitude that is positive versus an amplitude that is negative? How does it react? What causes this reaction? And how can I think of it? So what I'm going to do here is I'm going to talk about a couple of things. And one of the things we're going to talk about is just what is amplitude in general. So the amplitude, by definition, is the distance halfway between the max and min of a function. The way I think about it is it's the height of a wave from a central value. So I find the central value because we're talking about sine functions and cosine functions, that I'm looking for the central measurement, or where the central values are, and then from there I'm looking at that distance to the height of one part of the wave. I'm not looking at the whole entire wave from top to bottom. And we'll talk about that. And literally this thought comes from this definition. So first things first, let's just talk about amplitude and really what it is and how it reacts and how it's created. So first things first, let's just simply talk about a linear function, because all functions are based off of the linear function. That's where it all comes from, is the basis, the foundation. So the very basic linear function we have is y equals x. And when we first started graphing just linear functions, most teachers did inputs, output tables. So you plug a number in for x and you get some direct output. Well, this is what we call direct variation for this one, because whatever I plug in for x, it's going to be directly, y is going to be a direct impact to it. So if I plug a 1 in for x, my y is a 1. If I plug a 2 in for x, my y is a 2. If I plug a -1, it's a -1. If I plug a 0, it's a 0. So then we learn, to plot these values. So here we go, plot, plot, plot. And what we have here is we find that it's a linear function. So then your teacher starts changing some things and says, oh, what's happening here? So one thing your teacher might do is they might introduce put a 2 in front of it. So what happens if I do the 2's? Well, if I were to observe just this side, notice that this is kind of just my 1 times tables. 1 times 1 is 1. 2 times 2, or 1 times 2 is 2. 1 times -1 is 1. Well, now I put a 2 in front of it. I'm now just going to say to you, hey, whatever my original one is, so original outputs, I'm now just going to say multiply them all by 2. All right, multiply them all by 2, and this will create my new values. So this becomes 2, this becomes 4, this becomes -2, this becomes 0. And essentially I still just have my 2 times tables. Now I don't want to go any farther than this, because this is the direct relation to the amplitude. The amplitude in a sine function is literally no other than a multiplier. That's all it is. It does nothing other than to increase the amplitude, the height of the wave, by a multiple factor. So a factor of multiplication. It's not like an addition. You're not adding the same amount to both sides. You're literally taking the original output and simply multiplying it by what that value is. It is a direct impact to the height of the wave and nothing else. It doesn't change anything at all. And I'm going to go a little bit more into why it doesn't change anything. So couple of things here that we're going to jump directly into is this idea of the sine function in the first place. Where did it come from? What is it? And the sine function is actually a ratio. It's a relationship when you look at the height or the output, or how far the point is from the x-axis, because remember y is an output that's mapped up and down. So this relationship, this y value, is a height. So we're talking about the relationship of a height compared to a radius of a circle. All right. So we're now going to talk about the sinus, the unit circle. So this right here, when we first started, you first start talking about the sine function, is the unit circle. The unit circle has a radius of 1. All right. So when we start to look at these, we start to say, okay, hey, if I have sine of x equals y, when we start actually plotting these to create the sine wave, we start looking at a couple of things, and we look at specifically when x is 0. Okay, we look at when sine of x, when we input this pi over 2, when we input pi, when we input 3 pi over 2, and when we input 2 pi. Okay, so sorry I was in the way there. those are the values we look at. And what we begin to understand is, okay, why is it that we get that the y value, so why is it my output for this 0 is going to be 0? Why is it that pi over 2 is 1? Why is it that pi is 0? Why is it that 3 pi over 2 is actually negative 1? And why is it that 2 pi is now 0? So where do they come from? Why are they? What does this mean? So again, this all comes back to the sine function, sine theta. Okay, so that's talking about the angular measure. And we're going to bump this into the idea of radian measure in a little bit. But sine theta, we're going to talk about angular versus if it's radian measure. So on here, this is the angular, right? So on the unit circle, we talk about angular because now we're talking about a point rotating around a circle. When we start talking about the sinusoidal wave, okay, so this is 0, 0, so we're going to do input, output, so 0, 0, input pi over 2, output is 1, 0, then negative 1, and then back to 0. Let's talk about what this represents and what exactly it is that we're doing here and where it comes from. So angular measure is literally talking about if I have a rotation, when I rotate this line to this point that is fixed to this line, how far away is the point going to be from the actual y-axis? Because remember the y, or the x-axis, my bad, from the x-axis, because remember y represents a height. So the relationship is, well, what's the height? Well, the height in this case will be measured from the x-axis. Cosine is the opposite. It's measuring it away from the y-axis. So for this particular one, notice, okay, that if we switch over to radian measure, the difference between radian measure is now I'm actually a point on the circle, and I'm talking about traveling along the actual circumference of a circle, which is where these pi's come in because a full circle circumference is 2 pi. So if I take 2 pi, notice that we have 4 quadrants. 2 pi broken into 4 pieces ends up reducing to this pi over 2. And these end up being the nice values that we kind of take a look at. So notice, why is the answer 0? Well, if I travel a distance of 0, what's my height going to be? It's going to be 0. Okay? So if I travel a distance of pi over 2 on the circumference, what's my height? Well, my height happens to be it's 1. It's a unit 1 measurement away from the x-axis. Why is it positive 1? Well, because we're showing a height and we're not showing maybe, the opposite way of height is a depth, okay? And that's where this negative 1 is going to come into play in a minute. So input is pi over 2, output is 1. Then we travel all the way to pi, right? And we find that what's my height? From the x-axis, and it happens to be 0 units away. The negative 1 is now showing the depth that it travels. So I have the height and the depth, but they're both just distances still being away from the x-axis. I go back to 2 pi, and I get back to 0. And notice all of this happens because we're talking about the unit circle, and we're talking about something that has a radius of 1. So what this now has is that when we plot it, here we go, we get our values, okay? So notice that my outputs, that's where they come from. So this graph is actually a graph that represents a height, okay? So we're talking about a distance to another distance. So this graph literally is plotting. So input is distance of travel. So this one here is distance, okay, to a height. All right, so how far away I am from the actual x-axis. That's what these two measurements are really looking at for the actual graph, okay? So now, let's say that we were to change this. So now let's say we were to change something called the amplitude. And the amplitude is literally what changes the height of the actual figure. Well, I've rewritten this. I've decided to solve this as an input-output function. So I have y equals r times the sine of theta. So essentially what an amplitude is doing is it's taking the original sine function that has the unit circle of 1, and now you're going to be introducing a new amplitude. So the amplitude is directly correlated to what is the radius of my circle. So if I were to say that this is a 2, so now 2 times sine theta, all right? And I take a look at that, and I start to map and see what happens. Well, what you begin to notice is that literally I'm not going to change. The nice thing about circles are unique. Okay, and why circles are unique is because every circle has actually a circumference of 2 pi. So, and it's all just going to be, well, 2 pi is the magic number. They don't have a circumference of 2 pi. But they have their 2 pi is the magical distance that we talk about with actual circles. So now, when I begin to look at this, okay, when I go to here, this right here is still talking about a distance of 0, okay? So I haven't traveled anywhere. So if I were to take a look at this just by increasing that to a 2, that's still a 0. But now when I go to this pi over 2 measurement, okay, I end up getting that the output is now a unit of 2 away. So what is this amplitude really doing? The amplitude is no other, like we talked about before, other than a multiplier. So it's literally just going to directly impact the height of my wave. So here's the original that was 1. Here's the original function again. Okay. So this right here was a distance of 1 unit away from that axis. Okay. What I'm now doing is literally multiplying. Now it's not an addition. It's actually a multiplier. So what I'm actually going to do is I'm going to multiply this output by 2. Well, 2 times 1 is 2. So it changes this function to having a height from its central measurement, and there's my central measurement that I was talking about, to a 2. But it doesn't change, okay, the values, the distance, how far I've traveled. So I take a look at this, boom, and there's that. So that's at 1, sorry, my bad. Go down to -2, so there it is, okay? So amplitude does nothing more than that. What happens is if it's negative? What does it do? How does it alter it? How does it change it? If it's negative, notice that it's going to do the same thing. So if I were to change this +2 simply to -2, okay, it's literally just now taking these outputs, and instead of multiplying them by +2, you multiply them by -2. And whenever you multiply something that's originally a positive by a negative, it just takes it from out of the positive realm and puts it in the negative realm. Why does it do that, and how does this relate back to this unit circle? Well, unit circles, when we first start looking at them and observing them, we measure counterclockwise, okay? Well, now when I put the negative, remember negative just says go the opposite, so now it just wants me to head to my depth as opposed to my height first. And that's what the amplitude does, and that's it. So when I now have this, if I were to make this sine of -2x, my outputs now just become the original inputs are now multiplied by -2. So 0 times -2 is 0. Multiplied by -2 is -2, 0. -1 times -2 is now +2. And if you follow around the circle, right, you can see I'm just going back, and then I get to my 0. So how does it change the original graph and function? If we're talking about what happens, I don't necessarily talk about it in the terms of reflections. I really just talk about it's creating inverse outputs, or the opposite outputs. So started at 0. Well, there is no 0 is a neutral number, so there is no opposite of 0. So if it were a negative, I'm literally now talking about going to my depth of the wave first. So here's the depth. And then I go back to 0. Then I go to the height of my wave. Then I go back to the central measurement. So hence why the wave starts off like this, because originally I was talking about going to its height. Now I'm talking about going to its depth. And that's all the negative does. Some people think about it as a reflection. Sure, the original one might look like a reflection where you're just reflecting your points. And what it ends up being is that if you reflect this, it actually ends up being a reflection of both around the x-axis, and it mirrors it on the left-hand side when you do that as well. So it looks like it ends up being that you kind of just fold the page here, and it looks like this as it continues on. That might be a little confusing to look at right now. But yeah, so I don't really think of them that way. I literally just think of my original inputs being just simply created to be the opposite, simply because I'm going to a depth as opposed to my height first. So I hope that helps in the discussion. I think the last thing I said I was going to talk about here was the amplitude and how people get it, just not to make too many halves of something. So if I were to take a look at this particular function, Notice that these zeros, okay, these are basically what I call this axis here on the sine function. These zeroing values are really critical values. It comes back and it puts it back at this central measurement that I call. So the amplitude is no other than the distance from that central measurement, okay, to the top of the wave. And it's a distance of 2 in this case. So that's where I use the central. The other way is the halfway distance between the min and the max. So if I take the maximum value, which is at positive 2, and I look at the distance between that and negative 2, well, from here to here is a distance of 2. From here to here is a distance of 2. Well, that makes 4. Half of 4 is just 2. So that's kind of where I get my idea from, where just find where your central measurement is. And for sine, it's pretty easy. You can basically think of shooting an arrow through these 3 points. There's your central. Your amplitude is a measurement from that central point to the height. So you can count them on a graph if you want. You can find the value. This value is 0. So from 0 to 2 is a measurement of 2. If you were to shift this up and down, say you were to go to here and your max is here, well, that's a distance of 1 because 1 to 2 is 1. However you want to think about that at that point. I hope this helps. If not, let me know and maybe shoot me a question, a more specific question, and then I can answer a little bit more if you need me.